In this lecture, we're going to be discussing quantitative and numerical abilities of animals. And we're going to begin by asking ourselves, well, why might having quantitative or numerical abilities be useful or relevant to an animal? And then after that, we'll discuss what kinds of numerical abilities animals might have. And there's going to be two systems that we're going to be focusing on. The first is called the precise small number system, which is used to track small quantities of objects. And the second is used for larger quantities, and it is called the approximate number system. And that's the one that's going to be the focus of part 2 of this lecture. So let's start by discussing the role that counting and numerical abilities might have for animals. But let's begin by reflecting on ourselves, right? For us, even for those of us who hate mathematics, right, it is impossible to imagine our lives without numbers, right? We use numbers all the time to carry out activities from the most mundane to the most challenging activities, right? So math is involved, for example, when you're counting the number of cans of tomatoes that you need to put in your soup. And in terms of science, it's obvious that you need mathematics. We can't imagine, for example, carrying out theoretical physics without calculus and other such tools. But obviously animals don't require and use mathematical abilities at this level of sophistication, right? Nonetheless, we are interested in what kinds of numerical abilities animals have. And interest in this topic has been increasing over the last 10-20 years. And this research has been set back or delayed for a long time because of the legacy of clever Hans, right? So for many decades, people didn't want to touch the area of the numerical abilities of animals because of clever Hans. As you'll recall, clever Hans was the horse that was said to be able to do multiplication, addition, subtraction, and so on. Now, the difference between more modern research into numerical abilities and the case of clever Hans is that in modern research on numerical abilities in animals, tight experimental controls are imposed. So let's begin by asking ourselves why numbers might be relevant or useful for animals. I've listed 3 reasons here. The first is that it could affect foraging decisions. Let's say that a chimpanzee is going to go leave her sleeping grounds in search for food, right? So should she go to feeding area A or feeding area B? Well, you might imagine that her decision might be made based on the number of the amount of fruit that's in one location relative to another, or it could be affected by the number of chimps that are already going in one feeding area as opposed to another. Another example where numbers might be useful to animals is that it could affect decisions on whether or not to attack animals that are intruding in their territory. So for example, if there's more of them than us, let's not attack, but rather let's go get some help so that our numbers are more favorable for the attack. And this kind of thing has been found in other animals, including lions, chimps, and howler monkeys, right, where these animals will not attack right away if they're outnumbered, but rather they will go and recruit other animals to help them in a fight, again based on numerosity. And numerosity could also affect whether an animal chooses to affiliate with one group or another, right? They might want to join a larger group, for example. So for example, mosquito fish choose larger shoals in order to blend in. So there's lots of reasons for why numerosity might be relevant for animals. Animal cognition researchers distinguish between two very different kinds of number systems that animals may possess. Right? So they distinguish between the precise small number system and the approximate number system. The PSNS, or the precise small number system, is used to represent small quantities of objects in working memory, typically in the order of 3 to 4 objects. Right? It's used to track 3 or 4 objects through time and to retain it in memory, while the approximate number system is used to estimate larger quantities and to make relative comparisons. So if you have one bunch over here and one bunch over there, which bunch is larger, for example? So it's used for situations where you're maintaining perceptual contact with these large quantities. Now, as I said, both are found in non-human animals and humans, right? And the approximate number system, for example, is a system that we use when we're prevented from counting and using numerical symbols like we often like to do. Okay, and we'll show how humans and animals behave in exactly the same way when it comes to estimating larger quantities. But the approximate number system is going to be the number system we focus on in part 2. In this part, we're going to be focusing on the precise small number system. Right, so the idea here is that many animals can represent, discriminate, and remember precise quantities, right, provided that these quantities are small. Right, so like I said before, 3 to 4 objects, depending on the species. So one of the first studies to demonstrate this was Hauser, Carey, and Hauser. Their study used free-ranging rhesus macaques. And what the monkeys did was they watched people place a different number of apple slices into 2 opaque buckets, right? Buckets that they could not see inside of. Right? So they put a certain number of slices of apple in one bucket, a certain number of slices of apple in another bucket, and they looked to see which bucket the macaques approach first. Right, so the macaques were not trained at all, and they only did one trial. So what they manipulated was the difference in the number of slices that appeared in the 2 boxes. Right, so the difference in the number of slices between the 2 boxes. And they found that overwhelmingly and unsurprisingly, the monkeys preferred to approach the bucket with, or the box with the more apple slices, as long as the number of slices in total was small. Right? It had to have no more than 4 slices in each bucket or box. Right? So, for example, they could distinguish between 1 versus 2, 2 versus 3, and 2 versus 4. Right? In each of those cases, they would go for the box that had the more apple slices. But when the choices were between 2 and 5 or 3 and 5, their performance was a chance. They simply guessed which one they should approach. Right? And this is interesting because if you look at the numbers, right, baiting 2 versus 5, it's a larger absolute difference than 2 versus 4, and yet they know what to do in the case of 2 versus 4, but not in the case of 2 versus 5. Right? At least when they have to rely on memory, when they're tracking specific objects. Similar results have been found with human infants. Right, I'm going to tell you about a study by Feigenson, Carey, and Spelke. And this one used 10 and 12-month-old infants, and they were presented with a choice between 2 buckets, right, again, opaque buckets with different numbers of graham crackers that are baited in each. The infants watch this happen, right? They watch a certain number of crackers being put into one and a certain number being put into the other, and they look to see to which bucket the infants crawl. Right, so they had to base their choice on memory because they simply could not see into the buckets. And again, as with the previous study, children chose containers with the larger number of crackers, but only if the number of crackers did not exceed 3 in a bucket. Right, so if there was more than 3 in a bucket, performance dropped a chance. So they could distinguish between 1 versus 3 and 2 versus 3 and 1 versus 2. Right? They would always go to the larger one. But when the choices were between 2 and 4, 3 and 4, and 3 and 6, or 1 versus 4, performance dropped a chance. They would approach a bucket randomly. Okay, so again, it shows that performance is accurate as long as the total number of objects is small. And similar results have been found with other species, including salamanders and chickens. Right, so now for the theoretical part, how are these small numbers represented? How are they stored? And the most common explanation is called the object file system account, also known as the object tracking account. And the idea here is that animals, like humans, have certain slots, what are called object files in working memory. Object files being used to track a certain number of objects through time. Right, one file for each object that they want to keep track of. So it's a perceptual representation. They can retain an image of it and a spatial location over a certain amount of time. And it's useful because it allows for object permanence, right? The ability to know that objects exist through time. They exist through time because they are represented in object files in working memory. But since we know that working memory is limited, there's only a small number of object files that can be stored by, say, animals or children. And here's a graphic representation, right? We have 3 apples being put in one bucket, 2 in the other. The little monkey is watching the baiting taking place, and since it's a small number of objects, he has object files for each apple going into each bucket, and so he can respond correctly when asked to approach a bucket. Right, so the precise small number system allows for exact discriminations between small numbers of objects. And it allows us to keep track of these objects through time by holding them in working memory. And there's also some discussion that this precise small number system allows animals to carry out some simple arithmetic operations. So, for example, there was a study with monkeys that saw an eggplant being put behind a screen, and then another eggplant being put behind the screen, and then when the screen is lifted, they might see either 1 or 2 eggplants there. And if they only see 1, they seem to look very surprised, as if they were expecting 2 eggplants to be seen, right? So it's as if they computed 1 plus 1 equals 2 and were surprised that there weren't 2 eggplants there when the screen was lifted, right? So the response here is driven by the fact that there's a mismatch between what's stored in their object files and what they're perceiving. All right, so that's the precise small number system. In the second part, we're going to turn our attention to the approximate number system.